Okay, so I think that we can start. Very good morning to all of you. Thank you very much to the speakers and also to all the participants for joining us during this big final event, Data Aggregation and Harmonization for a Sustainable Built Environment. So I will briefly just explain the housekeeping rules. Very briefly. So just for you to know that all participants, you have been automatically muted by the webinar. So if you have any question, please use the Q&A, the question and answer tool that you will find on the control panel. And then this webinar is being recorded. So next week, the slides as well as the recording will be publicly available on our channels. So thank you very much. And now I will give the floor to our project coordinator, Maria Perez Ortega. Thank you.
Hello, good morning, everybody. I will introduce the agenda, and then, we will see all the slots that we are going to go through today. First of all, welcome, everybody. These 5 minutes and also the house rules that Nerea just introduced. Next to this agenda presentation, we will have we are very happy to have our project officer from the European Commission, from CINEA, on board. He's going to introduce the European, let's say, the European strategy or context that is around the project, the rationale around the project from the European Commission strategy point of view. Then we will introduce what is the big project, which are the objectives of the project from the beginning, why this project is important, let's say, which are the impact that we would like, that we are having now at the end of the project. Then we will introduce the business cases. You will see very clear practical cases in which we are really validating everything that we have developed and let's say, defined during all these years of the project in very practical and clear business cases. So it would be very interesting to follow these. There are 6 in different countries, in different configurations. So I think it will give you a very nice overview of the possibilities, right, of the results of this project. Then we will have a short coffee break, minutes. So run to your coffee machines and grab a coffee. And then we will go in deep into 2 of the main, let's say, technologies / techniques that we have used in the project. On the one hand, semantics based on an ontology. So we will focus a lot on understanding what is an ontology, how to use an ontology, and why semantic technologies are important. The other one is AI. As you know, AI is now everywhere. We are going to give as well practical examples about how to use artificial intelligence in a way that, that we can really show an advantage, especially in our case, in managing buildings. We will have a panel discussions. Different experts are going to introduce their views on those 2 topics. And we will have an open debate, let's say, around these 2 technologies. Then around noon, 3 projects related to the LIFE program are going to introduce what they have done in the project, what they are doing in the project. They are related to the job that we have done already in BIGG, and it's important. We consider that it's important to have an overview of other projects that are working in the same context. And finally, we will have the conclusion by noon 30, 12:30, 5 minutes conclusion, and this is the end of the workshop. Thank you very much. So now, according to the agenda, is the opening by our project officer, Mr. Boudakis. So please.
Good morning, everyone. I'll try to share my screen. Do you see the slides?
Yes.
Okay. Good morning, everyone. I'm the project officer of BIGG, and I'm happy to be here with you and talk about the importance of data in the built environment and the relevant actions the European Commission is taking in that field. So this cover from The Economist is back from May 2017. And as you can see, it depicts the biggest IT companies like Google, Facebook, and so on as oil drilling platforms. And it gives to data the title of the world's most valuable resource. So data in the built environment is a key driver for efficiency, sustainability, user satisfaction, and informed decision making at both the individual building and at urban planning level. Data in the built environment enables the implementation of smart systems and technologies for efficient building operations. This includes predictive maintenance, energy optimization, and resource management, leading to cost savings and improved sustainability. Data-driven insights contribute to enhancing the overall user experience within buildings. Understanding occupant behavior and preferences allows for the customization of spaces, optimizing comfort, and increasing productivity. Data is also crucial for monitoring and managing resource consumption within the built environment. It supports initiatives related to energy efficiency, waste management, and water conservation, contributing to sustainable and environmentally friendly practices. And data analytics and modeling help in predicting and future trends, demands, and potential issues. And this is particularly valuable in urban planning, enabling authorities to make informed decisions about infrastructure development, traffic management, and zoning for optimal city function. And the importance of data in the built environment has been highlighted already from the previous commission, who established the Building Stock Observatory as part of the Clean Energy for All Europeans policy package. And several Horizon 20 topics had as the core activity funding related to data in the built environment. Some examples are ICT-enabled sustainable and affordable residential building construction designed to end of life, digital building twins, and big data for buildings. The last is from where BIGG Project was funded. And as a spin-off of one of the funded projects was the establishment of the Building Digital Twin Association, since there was the consortium identified that there was no association in that field. The European Commission adopted the European Strategy for Data in 2020, which aims at creating a single market for data that will ensure Europe's global competitiveness and data sovereignty. Common European data spaces will ensure that more data becomes available for use in the economy, society, and research, while keeping the companies and individuals who generate those data in control of them. The strategy emphasizes the establishment of common European data spaces to facilitate the sharing and access to data in specific sectors, promoting a common European data governance framework. A focus on creating standards and fostering interoperability to enable the free flow of data across borders and sectors, eliminating data silos, and encouraging collaboration. The strategy aims to empower individuals and businesses by giving them greater control over their data, as I mentioned before, which involves promoting data sharing, ensuring privacy and security through tools like GDPR. And by fostering a data-driven economy, the strategy aims at enhancing innovation and maintain Europe's competitiveness on the global stage. This includes leveraging data for emerging technologies, such as artificial intelligence and Internet of Things. The Commission has decided to move forward with the establishment of the European Energy Data Space, which aims to integrate diverse energy-related data sources, fostering a collaborative platform for sharing and accessing information across the European Union. It will focus on creating standards and protocols to ensure interoperability among various energy systems, promoting seamless data exchange and enhancing the efficiency of energy-related processes. By facilitating access to comprehensive energy data, the energy data space encourages innovation in the energy sector. It will allow stakeholders to derive meaningful insights, driving informed decision-making and supporting the transition to sustainable energy practices. And the energy data space is aligned with the European Union's broader energy and climate objectives, providing a foundation for evidence-based policy making and the regulatory decisions in the field of energy. Of course, in Horizon Europe, we continue with supporting research related to data in the built environment. We have funded several topics. Here you see some of them. In 2022, we funded the topic Smart Grid Ready and Smart Network Ready Buildings acting as active utility nodes. This year, we funded 2 more topics, intelligent data acquisition and analysis of materials and products in existing build works, and innovative uses of life cycle data for the management of buildings and building portfolios. But we don't stop here. In 2024, we are launching another topic titled BIM-based processes and digital twins for facilitating and optimizing circular energy renovation. And of course, more relevant topics will be in the work program of 25 to 27. This is all from my side, and thank you for your attention. And I give the floor back to Maria.
Thank you very much, Teris. Thank you very much for this interesting presentation, which is fully aligned with the project, with the impact that we are having now at the end of the project, and with the other projects that we will introduce afterwards as well. Okay, from my side, I would like to introduce the project itself, which are the objectives, which is the rationale behind the project. The presentation is going to be shared by myself and a colleague of ours, also in the project, Nicola from CSTV. So he's going to be focused more on the technical part, on the architecture definition of the solution. I will introduce the project overall. Next slide, please, Nerea. Thank you very much. The objectives of the project, let me say that they were very clear from the beginning, in the sense that the Commission as well was very clear in the call. When you need to manage data from buildings, the sources of the data are very heterogeneous. Data is stored in different systems, in different formats, and it's very hard to really benefit from this data in order to make decisions, in order to really have data-driven decisions on that. So what we said is that, okay, first of all, we need to rely on big data technologies, because the amount of data is huge. And second, big data technologies also allow you to integrate, to harmonize, to somehow make the data linked to be able to use it in a proper way. And then once you have the data, let's say the data is really useful, then how actually you use the data in order to improve your decision making, in order to have more elements to check, to monitor, etc. So we said, okay, and first of all, in the project, we said, okay, we will have different pilots, real buildings, getting the data out of these buildings. And in total, we have the data from more than 4,000 buildings in the project, from the 6 different pilots that we have. So first thing that we said is that, okay, we need to build the reference architecture to be able to manage this data, to collect the data, to store the data, and to really have this storage able to collect all this information. And then, okay, we need to harmonize it. It's clear there are from different sources. One thing is that you are able to collect it from different sources, but then you need to really make the data talk to each other, understand the data to really make it useful. And once this data is useful, then AI comes as one of the techniques more advanced than the regular statistics, for example, in which you can find relationships among the data that helps really building added value services for managing the buildings. Okay, so those three are, let's say, the pillars of the whole project: the big data, the harmonization of the data, and the use of AI advanced techniques to really use that data. Next, Nerea. Then on the other hand, we said, okay, if we are able to do all of these that we mentioned before, in which use cases are we going to test it? We want to have real cases that, okay, now we have a fantastic way of managing data, collecting the data, and use the data, but for what? We need to have the real cases. So we found, what we define is 2 different areas in Europe, in Spain and in Greece, in which these use cases are going to be developed. The ones in Spain, or in Catalonia, there are 3 different ones that are related to agencies of the Catalonian government related to the management of buildings. The first use case is about improving the benchmarking and the management of the portfolio of Generalitat de Catalonia, so the Catalan government. So we take the buildings from the region, the ones that are managed by this agency, and we really help them improving the benchmarking and the management of this portfolio of buildings. And another one is that we help them, thanks to improving the data quality, improving the way the data is used, improving the way they are issuing the energy certification of these buildings. And the third one is more related to the actual lack of standardization that was before, that was very related to, we have data for the whole life cycle of these buildings, but the data is totally heterogeneous and we are not able to manage to do anything with that. When we move to Greece, we have, on the one hand, 2 cases, which are, one is for EPC contracts, so those contracts in which let's say the ESCO company is paid back by the savings that you do. So accuracy on the predictions and the calculations of the savings is extremely important. This is applied in office buildings. The one in the middle is as well in office buildings, in which we improve the service related to optimizing energy, but always considering the comfort of the occupants of the building. And the last one, the one on the right, is about residential. We are working with one of the retailers in Greece. This will be introduced later, in which we are building services around flexibility, both in electricity and gas, for residential consumers for the customers of this retail. All of these cases are going to be introduced in the next slot, so we will go through them and you will see all the details about them. Next, Nerea. What was the context at the beginning? The numbers is true, as our project officer was mentioning before, it's true that the project is finished, so the proposal, let's say, plus the execution of the project, it's been a while. The situation has been improved, but still, even with the European initiatives and the regulation and the way that this is transferred to the members, still buildings are one of the main energy consumers. 40% is consumed by the construction sector. Now numbers are getting better in terms of how many buildings are energy efficient, but still there is a lot of room for improvement. Now countries members are applying subventions in changing windows, in heat pumps, or in PV panels. But still, on the other hand, if you can click, Nerea, on the other hand, there is still a huge lack of data standardization. And you can do certain measures, certain actions of renovation in the buildings, but still, when it comes to management of these buildings, it's very hard to do when the data is not really standardized and you cannot really use all the data. And that's the context of the project. You can do some interventions, you can do, whatever you want of renovations in the buildings, you can construct new buildings with new materials and so on, but the data is essential. And this is where the project is focused on. Next, Nerea. So, and normally there is a saying that is, okay, you cannot start the house from the roof, right? You need to start from the foundations. And to start with the foundations, this is, let's say, the, our best practice recommendation. Now, when ontologies are being used, many people start like, okay, I will map to ontology. Come on, wait. Let's start by aligning the data sources. You need to really establish the data exchange that will found the whole story. Once you have this alignment of the data sources, you get the information, you're able to collect this information, then you build your dictionary. You need to really understand what the data means. And then, only then, you can map it to an ontology. An ontology is something bigger, it's something established and something that is supposed to be a standard. Before trying to go to match to an ontology, understand your data, make your data dictionary, and then when you have your dictionary, you are able to find the ontology or the different ontologies that are able to represent your data. And this is in BIGG is very important. From the beginning, we understood that it might not be possible to map the data to one single ontology. Our strength in our strategy was that we consider that there might be several ontologies that need to be, let's say, checked and used in order to be able to represent all the data that we have. It might not be one single ontology. And this is, let's say, one of the strengths of the project is not to rely on one, but to find a combination of them that fits our needs. You will see these details later. Next. Then is Nicola will introduce this part.
Yes. Hello, can you hear me? Sorry.
Yes, Nicola.
Can you please go back so we can have the animations? Okay, thanks. Okay, so I continue the explanation, and I will now present you the overall architecture and the reference architecture framework which we have designed in this project. And of course, the start of this is the 6 business cases which Maria presented you earlier. So you can see all of them there. So next click, please. So all of them, you will understand that they are using different input data and different technologies. So some of them are requiring some weather data. We have IoT data flowing into these existing architectures with the different players. We have cloud applications, we have databases, and what we want, next step, please. For each of these business cases, we want to create some insights. Right? We want to use big data to have some insights about the data and to act back into these technologies to send back commands to the IoT that you can see down on the right. We want to have dashboards which are important for the deciders to make decisions. We want to send data to end users using mobile phones. So all this data, all these insights which are created by our framework need at the end of the day to end up on different technologies. So next slide, please. So the core of this is to build a toolbox, that we call the Big Data Analytic Toolbox, which has a set of different services, a set of different tools which are meant to help the designer and the data scientist to create these yellow insights that you see down there. Next, please. So this toolbox is actually a curated list of different statistical analysis, AI, business intelligence, machine learning components, which we have chosen with their open source, and we have given them in an open source toolbox, and because they are useful to create these insights. And we have even presented some sample pipelines of these different components to demonstrate how we can calculate some information and some added value information based on the different scenarios. So now the next issue that we have is that if we want to have one and one only toolbox, which is able to help on different building and energy related use cases, we need to have one model which is able to federate, as Maria explained, the different semantics and different matters that we want to tackle using this central toolbox. So this is the creation of the big standard data model for buildings, which will be explained later, which is, of course, based on linked data. And the vision of the framework is that our data analytic toolbox takes this harmonized data as input and provides some harmonized data as output. Okay, next slide, please. So now that we have this core requirements, but we want to have one and one only toolbox, you can see in the different business cases at the top and at the bottom that we have different types of data, which are these different shapes in different colors. Because of course, in the different cases, we have different background technologies. So we can have relational databases, we can have existing time series, we can have Excel files or JSON files, and all of them have different properties named differently with different semantics. So what we need is this yellow component that you can see on the top of a toolbox, which we call the harmonizer. So the harmonizer is a helper tool, enabler tool, which helps you to take any type of data and through a mapping file convert it to the big standard ontology in order to have this, to be able to convert these different data shapes into something which is standard, which is once again the ontology describing buildings, energy related matters. So, okay, next slide, please. And now in the architecture, we are only two missing components to fill the gap. The first one on the top is what we call the ingesters. These are a set of components which make it possible to get connected to different data sources. So for instance, we know that if we deal with IoT, we need something which is able to use the MQTT protocol, for instance. So we need an MQTT ingester, which is able to get connected to MQTT data sources and flow the data to the harmonizer and then to the toolbox. We know that in many cases, we use microservices as form as architecture. So we use a HTTP ingester to take HTTP commands, once again, flow them to the harmonizer and connect, which is itself connected to the analytic toolbox. So on the top, you can see these ingester modules, and we have created some of them which are proposed open source at the end of a project. And finally, after the AI toolbox, after the yellow brain component that you see there is a connector. You need to write a custom connector to convert this harmonized data back to the custom data from the different systems. And in the architecture, we name that controllers. Next slide, please. And what you see here actually is the big data reference framework architecture. So we have a document, we have a deliverable describing this extensively, proposing a state-of-the-art vision about what is the state of data science architectures and how we use that to implement a specific framework, which is the big framework, and that in order to connect these different components, you shall use event message bus. So we use Kafka in our version of a big architecture. But then we have designed all these components to be very versatile, meaning that you can use a very advanced architecture with message buses and things like that. But you can take each of the components as well to use them using on the command line or using Docker. So we really worked on how to package these components and how to make them available for the developers. So that's it on my side for the technical integration. Thank you.
Okay, thank you, Nicola. So coming back to, as Nicola was mentioning before, coming back to the expected impact, okay, of this, let's say this strategy that we took up around semantic data model. First of all, the data model is going to be open. It's going to be, it's already available in GitHub. By the end of the project, which is in few days, we will make everything public and available and usable by anyone that would like to use it. Okay. In terms of impact, let's say in terms of scope, the idea is that at the end, we are able to demonstrate that the different use cases with very different nature, totally different countries, type of buildings and needs are able to fit into this architecture that Nicola was mentioning before. And this is very, very interesting. At the end of the day, we were able to define this very flexible and very adaptable architecture in order to cover all of this. And also everything is standardized. All the communication in the architecture is standardized. So there is a standard input for the open analytic toolbox. This is very important that at the end, the toolbox, when you are really doing forecasting or doing predictions or sending recommendations, all this input at the end is standardized. So the same algorithms, the same models can be reused, which is one of the main burdens of AI nowadays, because you need to specifically develop everything for every different case. And this is very important. In the midterm, as we were mentioning before, these tools are going to be available. They are fully interoperable and they are fully adaptable to the new needs, right? So this is very important. They will be open, they will be available, and everybody can use them, and everybody can capitalize on the capabilities of make them interoperable. And let's say, considering this, one of our main contributions as well is the contributions to standardization of data. We are providing suggestions and recommendations for TNO around SAREF and other ontologies or let's say semantic-based data interaction. And we are also giving this as a contribution for these bodies. And now, finally, because we didn't mention them before, these are the partners of the project. You will have information, you will have presentations from most of them today. So you will meet them, you will see what they do in the different use cases, either in the use cases as building data provider and testers, or more in the technical side of the project. Okay, so that's our part. I think that now we will focus on the business cases. I think it's a very interesting part of the project, realistic implementation of what we have done. So I give the word to Oriol that will lead this part. Thank you very much, everybody.
Thank you. Can you hear me?
Yes.
Hello?
Yes. Yeah, no problem.
Good. I'm Oriol Escorsell. I work for the Catalan Energy Institute, and we are in charge of the first business case, where we develop a benchmarking and energy efficient tracking tool for public buildings. Next slide, please. Yeah, Maria already presented what the seat of the project. I'm going to just tell you what it was for us, our business case. We manage lots of buildings. At the end of the project, we realized that we have more than 4,000 buildings. They are spread over 14 government departments at the moment. So it means lots of different heads taking decisions, and they implement every year more than 100. They implement hundreds of energy efficiencies each year. Next, please. So when you combine all of these, we have a massive challenge. We have several data sources. Maria and Nicholas already explained them, but some are internal and some are external. Energy use, building information, and for example, and weather data. All of this needs to be collected by a group of hundreds of energy building managers. They are a skill force, but they are using their time on recollecting the data and not processing it. And finally, we have a target. It's a European target, but we also have internalized it, which is the energy transition. Next slide, please. So when we defined the project, we wanted to obtain the greatest value from the energy data, as well as improving how we collected the data and how we use this data to make decisions. And finally, all of this is to facilitate the energy management, to reduce it. Next, please. Along these lines, the features that we define is to build an open big data infrastructure. It's been explained already. In our case, we want to be able to do energy benchmarking using these advanced analyticals developed to compare both a building against itself and a building against its peers. And finally, the system that we've come up with allows to continuously gather the data. So it's not a static picture. We want to have a dynamic system. Next, please. The first business case, this benchmarking and energy efficiency tracking, is divided into different use cases. The first one focuses on the benchmarking part, and the second one on the energy efficiency measures. Both of them are operated exactly on the same buildings, but we divided it into. Next slide. Maria and Nicole already explained this quite well, but I wanted to show you which are the data sources that we had to use. As you can see, we have several just for this business case. All of them then get a map and harmonized, and the BIGG storage and the AI toolbox will be explained later today, but I wanted to show you this picture. Next. So in the first use case, we're doing the benchmarking and the monitoring, but first we had to collect the information and put it all in one place. We developed this platform, this web platform, to allow users to collect to see the data they've collected and to analyze it here straight away. This is an example of how it looks. And if we go to the analytics side, thank you, Leah, we can start seeing different analytics. We've divided them in lots of in types, energy cost and emissions, and both performance, savings, and benchmarking. I'm just going to show you a brief section of the analytics to see what we can do. When we move from the performance that just shows how the building evolved to what the use case was, it's benchmarking. The benchmarking analytics, after applying what we'll explain later of processing the data, we get to a view like this. For a single building or for the whole typology of buildings that you select, you can see where your building is. This seems trivial, but this allows energy managers to decide among their hundreds of buildings which are the ones that they have to focus on, simplifying their decision making and avoiding what I said before, having to gather all the data and then process it. This is straight away what they get. Next slide, please. Then going to the energy efficiency measures, registration and evaluation. In this case, we had a different challenge. We have to gather the data. We used to do it using an Excel file that you have on the left, but this Excel file meant that first we had to send one Excel file per energy manager. As I said, we had hundreds, meaning we ended up with hundreds of different Excel files following a similar template that we specified, but everyone filled it how they thought. That meant a lot of time wasted on our side sending it, and a lot of time wasted on cleaning it, because you can block cells in an Excel file, but people end up doing what they think is the best solution. With the solution that we developed in the right, we fixed most of the camps using the harmonization. We set common names for everything, and we forced some of them to be mandatory and restricted what they could put, meaning that we remove first the data cleaning step. We could spend the time analyzing the data, and now we only have to tell them, okay, go fill it up, and don't have to send hundreds of emails. It seems trivial, but it saves hours both on our side and on the energy managers, simplifying the whole process of gathering the data. Now we go to the next slide. This is just a picture of what we gathered. It seems low, but it's a lot of actions. This is hundreds of actions applied in a couple of years, and to collect this data, we only had to tell them just to fill it up. And since it's a system that's on all the time, that's working, it's continuous working, they don't have to do it in a rush, and now it's the collecting is completely simplified. And finally, if we go to the final slide, what we've managed during the BIGG project is to create a centralized data repository. This, with the information that I explained before above, this is simplified how the energy managers can do the decision making. Since we have also integrated these analytical tools, they will be how they develop will be explained later, but the development was focused on our needs. So what we have as analytical tools is what we define ourselves and the energy managers that was needed to make decisions when managing a large building portfolio. And we also managed to streamline the data collection, for example, the energy efficiency measures that I showed you, minimizing errors and post-cleaning, and saving countless of hours that they can spend on solving the problem, that they are not just gathering the data. And to show you how much this has helped us, this big solution, we've decided from the Catalan government to keep funding, and now we are shifting from the results of BIGG into an internal tool, adapting what's needed to our case and improving it on it. Thank you very much. Now I'll pass to the next speaker.
Thank you very much, Oriol. I just wanted to remind you all that you can leave your questions in the Q&A tool, and then after the presentation of the 6 business cases, we will have a slot to solve all your questions. So now let's dive into the business cases 2 and 3. So Jordi, the floor is yours.
Okay, hello. Can you hear me?
Yes.
Yes.
Yes. Okay. Let me. Okay. I'm Jordi Carbonell. I work by CINEA, the research center that belongs to Generalitat de Catalunya, and I'm going to present the business case 2 and 3. Let's focus first on business case 2. Business case 2 is related to the building energy certification in residential and tertiary buildings. This business case aims to demonstrate how the platform developed in BIGG is and its different components and data model can cover the data processing related to building the energy performance certificate, and how it's possible to offer new services related to this thanks to BIGG Project. Okay. This business case is split in 2 different use cases. The first one is related to the integration of these energy performance certificates with Inspire spatial data. Let's say that Inspire is a directive to aims to establish spatial information of infrastructure in the European community. And the second use case, the use case 4 of the project, aims to work on the possible adoption of levels in the certificates. Levels, let's say it's a European Union initiative to related to sustainability in the construction. Levels is a sustainability, let's say, assessment framework for buildings, and it aims to provide a common approach to assessing, communicating the environmental performance of buildings across the European Union. The next slide, it's the pipeline that follows this use cases. I don't want to extend much in the slide, just to point out that this is the flow that follows the data, and where we use the infrastructure framework developed in BIGG, the data ingestors, the mappers, the harmonizers, and of course the ontology and the data model developed in the project. The next one, this is the, let's say, the present more the schematic way that we are talking about, where we can see here that we have external sources in the first column, where we have information of necessary data input for the business case. This data is, or we develop the ingestors to collect this data. We develop the mappers and harmonizers have been created to transform this data in a format that follows the BIGG ontology. And this harmonized data then is stored in a database in a new format. And finally, it is made available to the end users in the presentation layer, or let's say the user interface. And this user interface can be the one presented by Oriol in the business case one, for example, or could be some user interface created ad hoc for this business case. The next slide, specifically talking about the data collecting and ingestor, just to quickly present the external sources where the data are available. The first one is the open data system of Catalan government, which offers us a summary of the data for all energy certificates of buildings that exist in the Catalan region. We are talking about more than 1.4 millions of certificates that we are processing. And the second source is the results of energy certification tool themselves. These tools of certification generate an XML file that contains both the input data and the results of the certificates. And the ingestors and harmonizers are made in the project for both resources. We have been created and are available for the public in our project GitHub, and are available to be used for anyone. The next slide, please. Of course, the data from this business case has been taken into account in the creation of the big data ontology or data model. It should be noted that the main interaction of this data has taken place in using the core of the ontology. Yeah, and of course the extension of building performance certificate, and also the extension of KPIs, the KPIs extension. The other slide, please. Here just a summary. We have an extraction of the big ontology, where on the top we can see how the certificate data is related to the building entity, and on the right side a partial example of fields or properties of these energy performance certificates and their additional information classes. It's just a sample of this data. And in the lower part, we can see how the result fields of these certificates are organized following the KPI execution of our ontology. The next slide. In this slide, we can see a bit more transformation, or let's say harmonization of data. Let's say in a more semantic transformation. In the other slide, we have been seeing how the fields are related to each other. And this slide, we can see how the original names of the fields that we had in the original sources have been transformed or are being repointed to the names or fields available in data model created in the BIGG project. Okay. The next slide. Here we have let's say a sample. Let's say all of the data processed have been implemented over the CINEA infrastructure. This CINEA infrastructure follows the reference architecture framework developed in BIGG. On the left side of this slide, we can see a global scheme of the components that our big data uses. And on the right side, we can see a graphical representation of how this harmonized data has been stored in a graph database. In our case, we are using Neo4j, and we have the relation of different nodes and different information that we have in this use case or this business case and how this could be related and reuse it then on the final user applications. The other slide. Let's talk about more specifically the outputs of the use case 3. Okay, specifically in this use case, explore the interaction of certificates with Inspire spatial data format. The next slide. We would like to note that the spatial data in Inspire format has been extracted directly from the cadastral site of Spanish government. This data is already available in Inspire format. And as the certificates obligatory include the cadastral reference, the link between the two data sources, the building energy certificates and this cadastral information has been direct. Thanks to this data link, it's possible to explore the certificates at a spatial level and quickly answer questions such as simple questions, for example, what are the municipalities of Catalonia and their geometries? What are the surface area of buildings within a postal code, for example? Or, for example, what are the worst performing buildings in a year with within a postal code? Okay. The next slide, please. Especially to explore the certificates, a demonstrative user interface has been created. Okay. Where in this example, we can see on the right side of the slide how we can select a geometric zone by creating a polygon on a map and explore the certificates of this selected zone. The results on the right side of the slide, we can see the benchmarking analysis of the energy intensity use, for example, one of the indicators that we have, of the that are collected in the selected zone, and where we can see the frequency distribution of this KPI together with the median of these samples collected. Okay, and this could be seems a right demonstration of how this interaction could give us more valuable services for this use case. The next one, we now look at use case 4 of the project, the interaction of the building energy certificates with levels indicators. The main objective of this use case is to demonstrate when in the future the alignment of building energy certificates with levels indicators is achieved, that the BIGG platform is all ready to process this data. Okay. We would like to note that levels initiative is still under development, and we will see that not all indicators are yet studied in depth. Okay. The next slide. Here we can see the 6 macro objective of levels. Let's say that 1 and 2 macro objectives are directly linked on the current certifications data, and the others require additional data to be that are not available in the building certificates. And these 6 macro objectives are divided into different indicators, and we have been preparing the big data model to host these indicators that are currently defined in the levels initiative. And in this use case, also we have meet with responsibles of energy certification of hub of Catalonia region. We presented them the levels indicators, and we have analyzed the necessary data to be introduced in the certification to achieve the indicators of this initiative. But obviously, the modification of certificates are difficult in a short time. And it is a mandatory legislation for the citizens, no? And so do we need to see clearly we see the clear interest of the adoption of this, but it requires enough time for the real integration, no? Here in the third column, we can see the KPIs that we are created in order to store these indicators when these are available in the future. Okay. All related of this ontology and these elements are placed also in GitHub and open it to use it for anyone. The next slide, please. Let's say that as conclusion of this building case 2, we can say that the necessary developments to process the building energy certificates data have been created. We have been created the ingestors, harmonizers, and also we have prepared the big building data model to store all of this information. And we can say that thanks to these developments, it's possible to offer value-added services related to this certificate. Okay. The next one, please. We'll start now with business case 3. Business case 3, it's called building life cycle from planning to renovation. Let's say that this business case is more focused on the interoperability of data. The main objective of this use case is to demonstrate how to BIGG Project help us to interoperate building data, and this interoperability can be both between the individual building systems that we can found in a single building and the interaction of the BIGG platform with other external. Okay. Next one. These business cases are split in 3 different use cases. Let's say that the first one, the use case 5 of the project, it focuses on interaction with data of different systems that we can found during the life cycle in a building. And the other use cases are related with interoperability with external platforms. The use case 6 with the DIP platform. DIP platform is the European platform, the reference European platform of energy efficiency measures applied in buildings. And in case of use case 6, is there interaction of European Building Stock Observatory. Let's say that it's the platform who aims to or intends to aggregate the building data in European context. Okay. The next one, we have here the pipeline that follows the business case, where we have the data ingestion, the data harmonization and storage of this data, and the presentation layer of this data. Okay, the next one. It will focus on ingestion chapter. Here is a schematic of ingested and harmonized data. We connect remote building management systems maintenance control systems. We connect energy efficiency measures collected in the use case 2. We also collect building performance certificates as we have presented before, and different information. I would like to point out the amount of data that we are processing. We are processing about 900 buildings, these buildings with more than 36,000 of zones, and these zones contains 71,000 elements or assets, and these assets has 600,000 work orders, and with more than 200,000 registration points, and these registration points generate records every 15 minutes. So we are processing a lot of data and interconnecting a lot of data thanks to this business case. The next one, here we have we can see the implementation. If we focus on use case 5, you have the implementation of the different systems and how this data is implemented over our database. I will remember that we are using a Neo4j database that is a graphical database. And here we have one example in the right part of the slide. We have in orange, we have a building node. This node is linked to their zones in the red node. And these zones contain different assets in blue, and also could have different work orders that we have here in yellow. And also these work orders have different typologies that are preventive orders or corrective orders and belongs to a maintenance service. Okay. The next one. Here we can see how these linked data could be presented to the final users. Let's say it's the implementation of the results in the presentation layer. Could be something like this. We have here in the right side of the slide, we have the, let's say, the field of the file of buildings, where if we focus on the lower part, we can see how the user can go deeper in the building, can see the zones of these buildings, and each zones we can explore, for example, the area of this zone, the devices connected in these zones, or here we can see the elements, the lighting, electric power, and the orders also that this lighting electric power has. Okay. And this could be one presentation to the final users of this use case. Okay. The next one, it's more focused on use case 6, the interoperability with the platform. We are using the same, let's say, user interface presented in the use case 2 by Oriol. Here we have the list of measures applied in the buildings, and we have here one button. This button collects the energy efficiency measures that each user has access and generate an Excel file in a format required by DIP. No, the next slide, please. Here we can see an example of these exchanging files, and this button generates this file, and this file can be exchanged directly with the platform. Okay. The next slide. Here we are finally in the use case 7, that it's about the interoperability with the European Building Stock Observatory. In this slide, we can see in the user interface the list of ingest certificates for one user. And this case, in this case, we don't have defined the exchange file as was the case on DIP, because the European Building Stock don't have this defined. But if we go to the next slide, please. But one thing that we have, Building Stock Observatory have passed to us granular fields that could be of interest of them in the left part of this slide. And we can see in the right part of the slide how BIGG have defined these fields, and they have been harmonized. So when Building Stock Observatory defines the exchange format file or API, we can conclude that the BIGG will be able to provide this information to the Building Stock Observatory. And the last one slide. As conclusion of building case 3, we can say that the use of BIGG platform clearly favors the data interoperability between individual building systems and also with external applications. Okay, and that's all from my part related to business case 2 and 3. And I think that we can go to present the business case 4. Thank you.
Thank you, Jordi. I think you are hearing me well. So hi, everyone. I'm Anthony Ullman, working at Alexia, which is an energy service company based in several countries in Europe, which was responsible for developing the artificial intelligence toolbox, which we will have a focus later on, but also responsible for 2 pilots as well. Let's dive into the first one, which is the business case 4, energy performance contract management in large commercial buildings. Thank you. So in energy performance contract management, the key lies into the ability to collect, analyze, and highlight diverse data types without degrading the model being used. So our solution integrates the ESCO knowledge, combining it with the energy management system trained, which involved new machine learning and artificial intelligence techniques to use non-linear functions to help improve the current linear model being used by all the tools into the market. So the first step was to collect and standardize the energy performance contract and the client data. So Alexia, as the ESCO, provided its knowledge into harnessing data from metering equipment, but also all the contractual terminology and business modeling of the energy performance contracts. On the other side, our partners and the energy management system developed all the AI toolbox and the actual solutions being used later on to generate a big data model by selecting best data sets and best influencing factors. If you can click Nerea, please. Thank you. The second step was to develop a solution, a real-time solution to track energy performance contract guarantee and efficiency. Also to follow up all the data, considering the changes in conditions, but all of that thanks to the energy management system that helps generate massive datasets, models, and energy performance dashboards. So if you can click on the other slide, thank you. The direct application and our solution was developed through this energy management system, which is the front layer of the solution. Behind everything, you have the Toolbox, the data model, which we're gonna focus later on. But the direct application is this kind of dashboard that was developed in 3 buildings, 2 at Cordia and 1 at Alexia as well. The one at Cordia was the large buildings where we made another models and compared this new big model regarding the actual models that was being used by the energy service company to monitor the energy performance contract. And the results showed that the accuracy of the model, so the accuracy of the model given by the AI Toolbox, makes the model more trustable than any linear regression being used classically by other tools. So we looked at all the APM VPV parameters that are commonly being tracked into this kind of project, and we showed that the big data model was more accurate than the linear regression. Also, thanks to this wide compatibility with many buildings, with many data sets, this model has been tested in other applications beyond energy performance contract, like for example, tracking the savings from energy conservation measures. So this has been developed by the energy management system, which is our partner in this project, Energies, and they applied it to among 1,000 buildings. So this was quite interesting to see how the big data models could be used in many applications. Nehera, if you can click into the next slide, please. Thank you. The second pilot was the business case 5, which is comfort optimization, also in the same building as we saw previously. So this one focuses on buildings for occupants. In this business case, we managed to optimize building conditions for occupants through various forecasts. Most building management system available in the markets relies on centralized architecture that face several limitations when the topology or the organization of the building is highly distributed. And that is when the devices, for example, HVAC, solar panels, lighting system, etc. And the places where the people are, like the rooms, the offices, the zones, are located in different parts of the site and buildings or even locations. So that's why a central solution lacked robustness, and a distributed architecture, appears to solve these limitations, help generate deeper insights for forecasting demand and make good assumptions for energy consumptions. So the first forecast was using the weather forecasts, optimizing the comfort through weather forecasts. So it used 24-hour data in advance, making proactive matching of energy demand and supply based on this forecast. The second was using the occupancy of the buildings, integrating data occupancy from the system, and make a proactive adjustments of the thermal conditions based on this forecast. The last one is using the price forecasting, which has not been tested in the actual solution, but all the system is ready to be used for integrating energy prices alongside weather and occupancy. If you can click on the next slide, please. Thank you. So the conclusion and the direct application of this business case is that we tested it on the site we commented before. The results are quite well because we managed to shut down the device, remotely through an API based on the demand of the building. So the actual tracking of the savings showed that we had a 15% savings compared to normal conditions just by shutting down the heating power regarding several conditions like occupancy, weather forecast, and so on. So both these business cases, 4 and 5, showed that the power of the big data model and the artificial intelligence toolbox helped manage efficiently and more massively the energy performance contract, but also manage more automatically the comfort in this building. So this was the 2 use cases where we focused on this, and later on we will explain more how the AI toolbox and big data model were being developed. Thank you. Thank you, Nerea. You can switch.
Thank you very much, Anthony. And now we will go for the last business case. So, Thanasis, the floor is yours.
Sorry. Hello. Can you hear me?
Yes, we can hear you.
Perfect. I thought I had the I thought I had on the web, but I had the Zoom app and couldn't find it. So, hello, this is Thanasis Konstantinou from Heron. I will be presenting business case 6, focus on demand response, but for 2 energy systems, electricity and natural gas. So we have split the business case 6 to 2 use cases, use case 14 for electricity and use case 15 for natural gas. Now, the idea here is that business case 6 will demonstrate and exploit the flexibility and potential in residential buildings, mainly households, across both energy vectors, as I mentioned before, electricity and natural gas. Yeah. So the focus on electricity is an implicit demand response, which we will be explaining soon. And for natural gas, the idea is that end consumers can use natural gas. First of all, just to let you know that I will not be presenting natural gas, but here is the common part of the business cases. That's why I'm presenting it. In any case, for natural gas, the business case focuses on the managing of boilers for space heating, which participate in explicit demand response. That is, which has 2 objectives. One is to improve the energy efficiency by reducing the load, and the other objective is to contribute to real-time gas balancing services based on the market and system conditions. Next, please. So, use case 14. Here, as part of Heron's involvement in BIGG, what we have developed is with the contribution of BIGG partners. What we have developed is a recommendation service that allows participants, that basically informs the participants when should they decrease their consumption based on some conditions in the system. Mainly, we focus on the shares of renewables as part of the load, and we send them an SMS the day before about when they should decrease their consumption or shift it outside this period. So, for example, what we are trying to achieve with this service is to decrease the carbon footprint of residential electricity demand, not necessarily, although that's always welcome, by reducing overall consumption, but primarily by shifting heavy loads, such as the ones that are associated with the consumption of white goods and air conditioning, outside the time periods in which the renewables in the system are the lowest. To this end, what we're doing is we send an SMS from 5 to 5:30 Greece time, advising consumers to reduce with the recommendation. This one particular is in Greek, but we have for demonstration purposes some also in English. For those of you who do not understand, for those of you who do not understand Greek, what it says here is reduce your carbon footprint. We are advising you to reduce your consumption during period 2 to 4 due to low rest generation. Next, please, Maria. Now, the calculation about the percentage of the renewables in the system is done through a green tariff. Hence, the whole concept of implicit demand response. Implicit demand response is based on a tariff system, whether they are market tariffs or something else, but they are indirect incentives to the consumer to adapt to whatever request they're getting, as opposed to the explicit demand response, which would be a specific action that would have a specific monetary gain depending on whether the consumer accepts it or not. So for every afternoon, noon European time, Inetum, based on the methodology that we have provided, calculates dynamic green tariff. The green tariff is based on is a percentage of the system load that's been satisfied from renewable energy sources and hydro, as a percentage of the total load of the system. Now, this is based on the Greek TSO, the transmission system operator data, and some of you may wondering why hydro is not renewable, although it is. This is a convention that the Greek operator follows to differentiate between the controllable renewables, which is hydro, and the non-controllable intermittent sources, which are the wind and solar. So in any case, so we can have it more, so we can be more precise. This data comes 1 day in advance from the Greek TSO. This is part of the ISP, which is a part of the market, the balancing market system in Greece. And it allows us to have these forecasts of the loads and the renewable and hydro outputs a day in advance. That's why we chose this data in order to at least use the forecast of the ISP of our TSO. And that's very critical here because based on this forecast that the TSO provides to all the market participants, that is utility companies in Greece, this is how market decisions are made. So we are treating this data as much as reliable as it can be, given that the power plants enter into the market based on this data. So here you can see on the graphs that what we have identified for a specific date is the 4 hours, the 2 hours basically with the lowest renewable shares. So here is 21 and 22. This would be the recommendation would say that please reduce your consumption during these periods 21 to 22. Next, please. Now, the whole process is done by machine learning algorithm that has been developed by Inetum, the team in Inetum. So the idea here is that there is an estimate of the residential consumer for the next 24 hours, given the recurrent neural network methodology. So here, what this algorithm allows is to be able to identify the differences between consumption partners and the specific characteristics associated with the consumption of each consumer. And then through a clustering procedure to be able to group households with similar profiles. So the idea here is that the recommendations are personalized. We are not just saying everybody to reduce their consumption within the specific hours that the TSO provides as the data. Because if one consumer does not use this timeline anyway, then there's no point in asking them to do something that they wouldn't plan doing anyway. So next slide, please. So here is a validation of the predictions for the machine learning algorithm that has been developed by Inetum. You can see that this is based on the smart meter data that we provide, and there is a methodology to identify let's say the success or not of the next 24-hour steps. Next slide, please. Here is the structure of the solution for Heron based on the different layers, how the external data sources are fused to the ingester, and then based on the Kafka, it allows to be used by the service providers, and consequently from the service provider, which in this case is Inetum, and consequently for the service users, which is Heron. Next slide, please. Also here a little bit detail on the API and the method and the let's say infrastructure of the service for regarding the ingester and harmonizer components and that could be found in BIGG's GitHub repository. Next slide, please. And here is, let's say, the infrastructure that makes this thing work in the consumers' houses. So first of all, the smart meter, which is the little thing in red, is installed. It's quite elegant and small. Then the smart plugs that we use, and the smart plugs we use to validate whether some of the users have pilot participants have followed the advice or not. And then there is on the end there is a smart relay which measures the specific, allows us to be able to calculate whether the water boiler, not the natural gas boiler, the water boiler that's used for heating into the houses that do not have natural gas independent. So typically homes with central heating. This allows us to measure, to identify whether the boiler is used and then measure the consumption. Next slide, please. The user also has access to some interfaces in order to be able to view their consumption. We provide them access to statistics real time on power, voltage, and energy, real time and in terms of time series, so they can go back and track their consumption for, let's say, the customized amount of period. Let's say they want to do 1 week or 1 month or 1 year or whatever they want. Next slide, please. And similarly, we provide access to the data for the relay, as you can see, and for the smart plugs that are used. So the dashboard also applies to these devices. Next slide, please. Here is a typical interface that how the recommendations that Inetum provides, how we receive them at Heron, and what we do is we would identify. So Inetum provides us all the periods. So it provides us all the 24 hours. Actually, the peak 1 and peak 2. The lowest and after that lower renewables and energy sources. But then we select the lowest. And because we want also to, if there is only 1 hour in peak 1, which sometimes it exists, we always try to choose an adjacent time period. So we do not want to provide the recommendations that are, for example, saying at 12 to 1 and then at 7 to 8. If there is a small, if they fall within the same category, so that would be P2, we would try to merge them so they are in a continuous, let's say, if it's possible. That's not possible all the time, but that's what we're trying to achieve. Next, please. So what we demonstrate through this use case is that we were able to use a big data model for buildings to be able to store and harmonize the data. Smart hope that was something went wrong here, but in any ways, electricity consumption data. And what we focused here was on the deployment on smart meters, on electricity smart meters for the use case 14 because also in Greece the DSO do not yet have installed smart meters for electricity. So we're trying to install it at clients' homes and to develop a service that will allow them to shift their consumption in greener periods in order to be able to claim that we have contributed into reducing the carbon footprint of the of residential consumption. And that was all for use case 14. Thank you very much.
Hello, this is Stratos Keranidis from Toolbox. Can you see my screen?
Yes, we can.
Yes, and we hear you.
Thank you. So we proceed with use case 15, which focuses on exploiting the flexibility potential of natural gas consumers. For the needs of our pilot, 100 households that are equipped with legacy natural gas boilers have been upgraded through the Domex smart heating controller to enable the optimal management of their space heating. Through this kind of equipment, we managed to implement two services. One is the energy efficiency improvement service, and the second is the offering of demand flexibility. In this slide, we present the adoption of the BIGG reference architecture for the case of our pilot. So specifically, 4 components have been implemented and integrated. In green, we present the 2 components that have been custom developed from us for the needs of the pilot, while the blue components, the harmonizer and the AI toolbox, have been integrated as BIGG components directly. 2 specific user interfaces have been utilized over the past 3 years. More specifically, the smartphone application has been used by end consumers for remotely managing their space heating and also for providing their comfort limits. And second, the portfolio management dashboard has been developed throughout BIGG, and it is offered to the energy supplier to monitor in real time the progress of various metrics and KPIs for the overall managed portfolio of gas consumers. So we start with the energy efficiency trials. These have been executed over the past winters of 22 and 23. We managed to have more than 100 households participating actively in these kind of trials. So in total, we managed to achieve up to 35% of savings and to maintain their thermal comfort in the order of 94%. So in this slide, we visualize the amount of savings that have been estimated for the whole winter period for a reference household. We can see that based on our calculations, 32% of savings have been achieved. And how did we achieve this? We managed to operate the boiler for a higher percentage of time in energy efficient settings, namely in boiler outlet temperature, in terms of boiler modulation, and finally in terms of boiler efficiency. The overall process has been transferred also in the case of heat pumps. So we took a big step further than the proposal phase and put a lot of effort to translate this from natural gas boilers to heat pumps. And we integrated our solution with multiple HP vendors and also tested it with the same kind of tools. Next, we proceed to the flexibility service. In this case, we experimented with 2 scenarios. First, with consumers which had to reduce their gas consumption in order to match the shortage of natural gas supply or the occurrence of high upward prices. And second, the case where consumers had to increase their gas consumption, which is which appears essentially in cases where we have low downward prices or excess of natural gas supply. Both cases considered the guarantee of user comfort limits in terms of the room target temperature and the minimum room temperature increase rate limit. So in both cases, the supplier calculates the total imbalance and estimates the target imbalance that needs to be corrected by our service. So for example, given the target imbalance, and in the case where we have upwards consumption, we need to enable the smart control to decrease the consumption for the reference time interval. So in order to do this, and in collaboration with IMEC, our colleagues that implemented the AI toolbox in this case, we managed to assess the expected consumption over the next 15 minutes interval. We ranked the boilers by the highest expected gas savings, and then over the control interval, we continuously controlled the boilers that participated in this DR event so that we are able to achieve the target power that has been requested by the supplier. This is the tool. It's a Grafana dashboard that we use to closely monitor the power usage in real time and to dispatch the control actions for each specific household. And in this slide, we just present two specific events, one downwards DR event and one upwards DR event. We can see that in total, over our trials within February 23, 80 DR events were executed, each one lasting for 10 minutes. And we managed to achieve 8 participants that have been active in total of the 10 participants that joined the trial initially. Regarding the conclusions, through use case 15, we managed to integrate the big data reference architecture and the various components of BIGG to store and harmonize data from various sources, specifically smart heating data, weather data, and gas market data, to promote the delivery of the two services for energy efficiency and demand flexibility to natural gas consumers. So essentially, in the case of Greece, where the DSO lacks the deployment of smart metering infrastructure for natural gas as well, through the solutions that were developed in use case 15, we managed to achieve both energy and cost savings through load reduction for the end consumers, and also monetary savings for the consumer itself and savings for the energy supplier through their participation in flexibility markets. And both were guaranteeing that the user comfort levels were satisfied throughout the trials. Thank you.
Thank you very much. We are a little bit behind schedule, but I think we could take a couple of questions. So I see that my colleagues have been answering in a written way some of the questions, but I can see here a question in the panelist chat from Daniele Antonucci from URAC. He says, great job. A question. Could you explain how an external user with their own data can interact with the platform? Can they do it independently, or do they need to contact you and receive support? I'm thinking specifically about data modeling with your ontology. So I think this question was written during the presentation of the Catalan business cases. Maybe Oriol or Jordi can answer it.
I'm not 100% it's for me, this one. It's more for the data modeling. Jordi or
Yeah, finally.
Okay, here.
I'm here. Sorry, I couldn't find the button to unmute me. I understand that the question is related with integration of BIM models. We expect at the beginning of the project to have a lot of BIM models from the Catalan government. Finally, we have prepared the ontology and the model in order to can collect all the necessary inputs for the use cases that came from BIM models. We are following, you will see in the ontology presentation that we are following SAREF ontology, and this SAREF ontology is aligned to IDF ontology, then we are available to store all the necessary inputs from the model, the BIM models that we then we can conclude that the ontology and the model it's prepared to store this data. But finally, in the implementation of the use case, we only have one model, real model of the buildings, and we have been working on this model, and we have included this data for the BIM model also in the use case. I don't know if this answered your question.
Yeah, probably it is not referring to my question, probably it's another one from Alan, probably it's one related to the BIM. For my side, it's much more related to the EPC. So I'm just thinking about if you are going to use another data set of EPC coming from another nation. So the part related to modeling of the semantic modeling of my data sets will be made automatically, or we need every time we need a support. I mean, it's something that also struggling in other projects. So understanding in which way it's possible to help the user to upload the data automatically and after model the data set using a specific ontology. This is why I found out that there is some problem or issue for the external user to understand in which way to model the data. And yeah, my question is if we need, if I have on my data set, I have to define by myself all the points, or there will be like an automatic support to create the data model from my data set.
In my understanding, our trials are made also using building EPCs coming from Spain format. But in my understanding, the final outputs are really closer because are following an European directive. Then the main part of these outputs, I think that could be aligned in the same way, or just in the same way that we are using in the tools developed in the BIGG project. But for sure, it depends on the specific implementation of the European directive in each country. Maybe some adjustments should be done in order to ingest some fields or extra fields in some cases for the data provided by from different countries. Let's say, this is my perception. We didn't try it with other
data set. Okay, it is also available the work that you have done with the Spanish APC, so it's possible to give a look, check it, and
it's all on GitHub.
Okay.
It's open and it's public. You can.
Yeah, because I gave a look on the ontology, and I think that is very useful, and probably I will use also in our moderate project for the part related to the APC. So following also the way in which you have modeled the part related to the Spanish APC will be very helpful. And yeah, after I will check on the GitHub for this part.
You could find there the ingestors, the mappers, the harmonizers, and also of course the ontology that we use.
Okay, thank you.
Great.
Okay, so yes, we can continue with you, Jordi. I think this question is also for you. It says, it's a question from Alan Sarli. It says, I understand that BIGG has put in place a framework for a network of data dictionaries and established kind of a governance model for data dictionaries. In the development related to BIM information and processes, use case from Jordi, if I'm not wrong, has it been considered to leverage on an ISO 23386 for defining properties or attributes in the data dictionaries and a methodology for authoring and maintaining them in a BIM process?
No, see, this is exactly what I was talking about previously, related with the BIM models. Our expectation was to work harder on these BIM models, but finally the data providers doesn't have really available models to be shared with the project. And finally, the only thing that we have been done it's to work on the ontology to be sure that we can ingest the data provided by the BIM models and anything more related with this.
Okay, thank you, Jordi. And then we have the last question. It is from Hoop Kaisers, and it says, did you also check the end user household satisfaction?
Yes, I think this goes to me. So for every household, we continuously monitor the deviation from their target temperature. And whenever it exceeds 1 degree, we record this as let's say, a negative point. So when we monitor that a given household has achieved 94% of thermal comfort, we consider that they have not exceeded this comfort limit by 1 degree. And we didn't collect directly feedback from the end users, but we sent out surveys and gathered their feedback in the long term. And it has been quite successful. Just to give you an essence, in the baseline mode, it is very easy to have temperature overshoots above the target temperature, which is also considered not accepted by the end user. So it's an easy to fix situation with the baseline mode.
Okay, thank you. So I can see that we are behind schedule, so unfortunately we will have to skip the coffee break. So let's go now with the ontology and the AI toolbox. I will give now the floor to Sampath and Edgar from the BIGG Project.
Thank you, Neria. Hello, everyone. So I'm Sampath. I'm a data and AI consultant from Inetum Real Dolmen. Thank you to all the panelists. From ENERGATE, we have today Katerina. From DigiBUILD, we have Dimitros. And for MODERATE, we have Daniele. Thank you, everyone, for coming. So we'll first start with the ontology. So Edgar will present it, and then we'll come to the AI toolbox. I will present it, and then we have our panel discussion. So Edgar, up to you. Thanks.
Okay, thank you so much for the introduction. Yeah, I'm going to talk about how we develop the ontology and which way can you see like in detail in these two white papers that have been published already, right? So next slide, please. Yeah, from the beginning, we like developing methodology to do this, and starting like with the a data model, like the standard data model for the to cover all of the use cases of the project, and which consisted in these two phases, like the development and use. Starting from the data requirements and the identification of some ontologies, a big standard model was proposed as the first, like in the first iterations. Then with these existing ontologies, we were focused then in reusing concepts and the creation of the missing elements to first get or obtain a data model. which will be the base of the standardized BIGG ontology. Yeah, afterwards, with this, the ontology alignment with like the once again existing ontologies brings us to the standardization like proposal now. The mapping of existing non-standard datasets was also part of this methodology at the beginning in order to get this done, right? Next slide, please. But what happened like with the development of the ontology itself, like in more detail? Next slide. Well, it happens that the development of an ontology is one of the like main assets that are outputs of a whole linked data cycle. So it's like the methodology inside of a methodology, right? So starting from the use cases, the data requirements, once again, and the data required for the use case. We extracted the data, analyzed it, and defined some starting ontological requirements. The resource naming strategy also is part or an important part for getting or for reaching to these resources afterwards. And that brings us to the implementation of the ontology. And that part, we have the code of the ontology, which was validated using some other external tools that allows that. And during the convert phase of this cycle, the pre-processing, mapping, and materialization was performed, and afterwards a data validation also took part of this phase. Then linked data happened during the load and inference. We verified the ontology through queries and linked also to external data sets. Yeah, now the ontology is published, and some of the data sets are also open to be like queried. The exploitation phase, as we saw in previous use cases, like were depicted, no, what some service platforms that are now in production phase. And this cycle happened multiple times when new requirements appeared, and when some bugs were detected, the cycle was repeated. So yeah, next slide, please. This cycle allowed us to develop the ontology first as a core, and then for the extensions of it. Right, the core ontology borrows some of the already existing concepts, as we will see in the next slide. Yeah. We reuse concepts that come from the standard SAREF ontology, also from its extensions, such as the SAREF for buildings, SAREF for city extensions, and also from the we borrow other concepts from other standardized vocabularies, such as the SSN, and Moreover, the widely used ontologies such as the FOV, the schema, BCard, GeoSparkle, GeoNames, and more. As you can see in this slide, the white boxes are the reused concepts, whereas the blue ones are the ones that we included in order for us to solve the use cases of the project. Yeah, concepts such as energy meter, cadastral parcel, or energy supply point were key concepts that were not included in these already existing standardized vocabularies. And also, as a matter of demonstration, in the next slide, we can see one of the extensions that was created also with the linked data cycle. I just show you a couple of slides ago. Here again, we are reusing the core of the SAREF ontology with the SAREF for City extension that are already we have the key performance indicator concepts and assessments. And we bridge the gap of like the analytics part and the machine learning also always have like concepts, and with this extension. Yeah, next slide. This is a short summary of how the data is processed. We have the raw data coming from different data sources, and then we generate some mapping files that the harmonizer will ingest and convert it into RDF data, which is already linked data, and is available to be queried with another standard language that is called the Sparkle query language, in which we have also included some of the existing ontologies as I mentioned before, right? We have concepts coming from the IFCO, SAREF and SOSA as well. And finally, the results of these queries brings us to make these data sets interoperable. And we can make use of them to solve the use cases of the project. Yeah. Next, please. Yeah, and that's a short summary of the ontology. So we can move to Sampat. Thanks.
Thanks, Edgar. So let's try to pick up the pace a bit. So artificial intelligence toolbox that we have heard from the morning. So as it stands, that you have artificial intelligence and how we perform or make it into a toolbox. Next slide, please. So first, the motivation. So right now, artificial intelligence, or to be precise, Gen AI, is very, very popular. But back in 2020, to understand and find that artificial intelligence should be used had really, I think, from a European Union point and also from our partners' point, was really, really important and timely development aspect, I think. What motivated us to shift? Of course, the complexity and the evolution, let's say, of the information landscape, that things are getting complicated and there are dependencies between different activities that is happening. So I think that's the main motivation to move to a machine learning or an artificial intelligence based system rather than conventional regression or conventional techniques. Plus, it will also help in maintaining the large scale functions of the data. The human capabilities will be enhanced if we use artificial intelligence, and to identify, let's say, subtle features that couldn't even occur to humans. I think artificial intelligence have proved to be very useful. So that's, let's say, the motivation of using artificial intelligence. Next slide, please. So how the development of the toolbox happened? It happened in stages. Okay, so in this slide you can see there are tasks. So let's not go over it because that's not the main point. The main thing is it's all started with the business motivation. That means the use cases that has been defined in BIGG, they were the driving force on how the AI component or AI toolbox should look like. Then once that has been defined, people, or let's say the team, went ahead with identifying which are the commonalities between different use cases, right? So which is basically common, which will be reused by all of the AI implementation in BIGG. Now, once they have identified those, they have identified that, okay, these are the common features. What is the existing modules or libraries that is already available? So it's not about reinventing the wheel, but being more, let's say, clever about it, of reusing the stuff that we already have. So once, let's say, it has been identified, existing libraries has been identified, then we started to produce, let's say, in terms of modules, in terms of techniques, in terms of the features in the AI toolbox. Now, once those has been developed, the preliminary version was in production for, I think, half a year to see, okay, we are getting the efficiency we need, we are getting what we wanted. And once all these functional blocks has been developed, integrated or assembled into the pipeline was the final phase. Now, after that, we had time to monitor it, see what we are getting out of it. And I think that comprises all of the development part of the AITB, the artificial intelligence toolbox. Next slide, please. So what does it have? It has 4 modules. It has additional things, but mainly 4 modules. First, what we tried to do to streamline the data preparation models. As you know, the harmonized output are coming, or harmonized data are coming in. From there, we try to find, okay, for the analysis, what kind of data preparations we need to do, what are the functions that we need to build. So outlier detection, calendar timestamp management, all of these things has been implemented and used by all the use cases. Next comes the data transformation modules, where you basically add features to the data before it goes into the AI model, where you try to profile, to add additional data like weather and calendar and holidays, this kind of stuff. Then it follows to the modeling module, so where you basically create the model, test the model, evaluate the model, and make the decision, okay, where or what kind of predictive analytics that we get out of it. And the last stage, and let's say for component, is the reinforced learning. So let's say it should be able to learn in a automated way. So that part is also there. Apart from 4, there are custom built modules available for each of the business cases because of the necessity that we found we needed to develop, but all are part of the AI toolbox. Next slide, please. So how does it fit in the reference architecture? So the data source, let's say it comes in on the first step 1, the ingestion happens. And then in the red dotted box, you see there is the harmonizer. And next slide, please. Yes, and the AI toolbox that comes one after another. And then after whatever analytics has been produced, it goes to the dashboards, external system, apps, and what for each segment or each business case or use cases that goes to the end user. Next slide, please. So everything is available publicly. All the example scripts, example documents, the documentation, as well as the Python and R. So these are so all of the things has been implemented in Python and R. those are also available. Anybody who has access to GitHub or internet can have it and download it and start working on their project. Having said this, I think we have I think 10 minutes to discuss and have an open discussion how what we have heard throughout for ontology, the use cases, and the AI toolbox, how does it connect or complements other. We don't need to go to to ENERGATE, to DigiBUILD and MODERATE. So these are 3 other European projects which are also a part of the cluster, energy cluster. I would say flow to the panelists. Maybe we should start with Dimitrios.
Hi there. Can you hear me?
Yes, thank you.
Yes, thank you so much. So, I mean, just to get the discussion going. My name is Dimitrios Rovas and I'm coming from UCL, but I'm here today representing DigiBUILD and some of the work we have been doing there that is very well aligned with the discussions we've had before. So just to start by, what it is that we're focusing on in DigiBUILD and how we approach the problem. We've taken a very similar approach. So we have a number of use cases that have been defined as part of the proposal stage, and they focus to broad sets of challenges. And then the second part in setting up the problem, it has been the understanding that there are people who are bringing in data, and it might be that these data are very heterogeneous and can depend upon stakeholder type, it can depend upon application or pilot type. So our thinking in developing kind of the data integration tools and the ontologies is that we should be inclusive in the approach of accommodating for very diverse ranges of data and data sets. So what we're doing specifically in DigiBUILD, we have developed and we are developing a programming model, which is some sort of abstraction in relation to delivery of portable analytics. That allows us to define computational quantities without specific implementation. For example, a zonar temperature, which can be computed from, obtained from a sensor, can be computed from some sort of analytic. And then underlying that and empowering that is our DigiBUILD ontology. The way we approached the development of the DigiBUILD ontology, which we're about to release the first version in the next week or two, and it will be public, is we did follow standard design patterns, ontology design patterns. So we collected facts and requirements, information requirements from our different use cases. And then we looked at reusing as much as possible existing ontologies that are well defined and available. For example, in our case, we created the taxonomy of the data that represents the amount of information we're interested in. So we are very much interested in buildings, building systems, and that building hierarchy. We're interested in users, but there is other domains like financial domains. Also, there is a district heating domain within the project. So then once we've completed the collection of the information requirements, we've done a coverage analysis mapping against existing ontologies. So much like BIGG, we looked into SAREF, being kind of the European recommended approach. We've also looked into the BOT, which is an upper ontology, which provides an integration framework. We have been using, and we're using quite a lot, BRIC and the real estate core as kind of more application-focused ontologies. And basically, the DigiBUILD ontology is following a very similar philosophy. So we're using and reusing concepts that are coming mostly from BRIC and real estate core, because we found that these align better with our ontologies, and then providing extensions only where this is needed and where this is needed. And also we're using aspects like FOF and SSN and concepts from kind of general ontologies. But I think the main part is alignment with real estate core, maybe SAREF, and then developing everything using those concepts.
So I see that there are several components that comes in together for the use cases that is necessary for DigiBuild. Right. Okay. Then Katarina, maybe you go next.
Thank you very much, and thank you for the nice presentation. To be honest, I'm not from the technical part of the project, but as we have also previously discussed another call with the BIGG project, we have so many things that we are investigating and are in common. I'm representing the ENERGATE project, which aims to facilitate the creation of an ICT-enabled energy efficiency marketplace. And we are going to bring together energy services on the one side and sustainable finance in order to accelerate the renovation rate of buildings. So we try to increase through this marketplace the chances for projects in buildings to be financed. Within the platform, we try to enable effective collection of project-related data, which have to do with the building typology on the one hand, but also risk-related data in terms of the project financial data, and all the data that are needed for a financing community, for an investor in order to know in order to invest in this project. And we do business matchmaking and aggregation in order to support both sides. So the users that we have mainly are categorized in three broad, let's say, stakeholder groups. The first group is the building owners, who own or manage a building that needs to be renovated and handle the different type of data. And we try to extract those data in order to do our calculation. The other group is the implementers, who represent companies or organizations that aim to support and implement the projects. And we have also the financiers, that are the institutions, the investors that want to invest. So we have several stages that we are now developing in order to release the first version of the platform in March. So the one is the fetch stage, where we collect the data. We have already pilot partners that have provided with data. We have a database with more than 500 energy efficiency projects in buildings. And we will use them for several services. And the process stage is where we do the calculation, the KPIs and all this stuff, in order to, on the one hand, aggregate the small ticket size projects, in attractive bundle of projects to be offered to the financiers, and we match them with the financiers based on their preferences. And the delivery stage, which has to do after the implementation of the project, with the monitoring, and we enhance the database with real information after the project implementation, in order to see where they stand as far as the efficiency of and meeting the targets is concerned. So when it comes to data handling, although we did explore the creation of an ENERGATE ontology in the form of common data model to store the information about the buildings, on a theoretical level, we later concluded that it would be preferable to use a relational database connecting the different type of ENERGATE platform users. So this will enable the matchmaking between the different stakeholder groups in the platform. However, the ENERGATE data model could easily be translated to ontologies and relationships between the different entities. And the ontologies could represent either user profiles or building profiles, and could easily go through data harmonization. But we mainly deal with, let's say, static data and not dynamic data or real-time data that come from sensors. So it is important for us to highlight the relationships and interactions between the different users, rather than concentrating on the relationships between, for example, buildings and sensors, as for instance in BIGG projects. So we're also exploring the possibility of handling real-time data generated by smart meter sensors that might be installed in the context of the renovations of the projects that will be entered to the platform and needing for financing. So this is a later stage, let's say. I guess that later on we will discuss on the several use cases that we have in the services, right? it's a next step.
Okay, thank you very much. Daniele?
Yep, so yeah, good morning to all. So my name is Daniele. I am a senior researcher at Eurocast Center, and we are also together with my colleague coordinating the MODERATE project. As I've heard so far, so there are all these projects refers to the same topics, same aims, and we are also taking about the same objectives. So MODERATE is a marketplace that also we are trying to connect the user that are the owner of data to, on one hand, sell data or provide data to different type of services. But one of the key point of the project is that we are facing is the part related to the make the data available and to be compliant with the GDPR. And to do this, we are trying to generate a model in which we are synthesize data because in this case, we found out that the statistical information about the data will remain instead to normalize or the data sets. So one of the core, as I said, is the synthesization of data that will be after applied on some analytics, different type of analytics that can be used by users, for in particular building user, for different purposes. One of the key point, as also we are facing here, is the partly to the ontology, but it's not a process that we started here. Probably also together with DigiBUILD, we have a background in another project that is Matrix, that is also a project that it's a sister project of BIGG, in which also here I was involved, and in which we also talk about the harmonization of data model and try to understand the way to harmonize the data. And as MODERATE or in other projects, the main issue is try to understand which is the better way to describe the data set, and after also push the external user to use the ontology, because most of the time we found out on the external side that this project seems to be like a theoretical study in which everyone provide information, but after they don't want to use. So this is also one of the process that we want to do. So start talking about with companies and said, okay, if you model your data set in using a specific ontology or semantics, after it will be much more easier to share the data and to understand better the data with the external user, but also in the future. So in MODERATE in particular, I'm modeling data using ontologies such as brick schema, as in DigiBUILD, and the real estate core is the ones that we refer, in which also I worked different years ago. But also I used Saref, iStack, try to understand which is the best one. There is also one from Google now, DigiBuilding from Ontology from Google. There are several I think action in this topic, in this field. Find out which is the best one probably is very, very difficult, because the topic is so large, so big, that is very difficult to understand which is the best one. But yeah, trying to model and to use this type of action on the data, I think that is very important. I also started to understand your ontology, in particular for the part related to the APC, because there is not too much ontology on the market that are based on for the APC side, and probably something that I want to exploit better and try to understand if it's possible to apply in MODERATE. As you said at the beginning, we don't want to create a new ontology or create a new points, but we want to use something that is already in the market, that has been used, and we don't want to rebuild the wheel, restart every time from zero, but starting from the work that is already done and trying to improve it and to use it in our case, also to exploit better the results.
Thank you, Daniel. Thank you very much. I think you also already touched upon my second question. Can you go to the third slide, Neria? Yeah. So, for example, as you talk about user acceptance, that has to be there for any ontology to become successful. I would like to hear your views from Katerina and Dimitros. Already Daniel mentioned that the user acceptance is one of the main criteria for anything or any ontology to become successful. How do you see in future, or for the energy market in future, to accept a harmonization layer or an ontology specified throughout Europe, if not throughout the world? What's your view, Dimitros and Katerina?
So maybe should I start? So I think that's a very nice and interesting question, and an open one for that matter.
Yeah.
So I can say what our approach is, and I think how that is contributing to this discussion. I agree with what was mentioned before, that you know, everybody who tries to get into that concept of data modeling, whether it was BIM in the past or now we're talking more about ontologies, is faced with kind of a big challenge of going through an alphabet soup of different ontologies and different aspects. So I think it looks very arcane and very esoteric, which is oxymoronic, because, you know, really we're talking about sharing data more easily and making them more accessible, yet the whole process seems to be too arcane. So the way we approach that at DigiBuild is trying to understand what the process is and of data delivery to end users. And end users in our case might mean actual physical persons, or it might mean applications. And I think one of the parts which is quite clear is that heterogeneous of type of data that we have, but also implicit to that is also the concerns that come with data sharing. So, for example, we have a case which is related to facility management, similar to what BIGG has been working on as a business case. And in that particular case, the facility managers of a building, which coincidentally it's a UCL building, are very much concerned about sharing that data because they're worried about liability. So to start answering that question, I think one of the parts is that we need to create on the research and technology development component the mechanisms and the methods to be able to facilitate and empower users to provide the data and make them accessible, and then control the data that they have. And what I'm saying is very similar to the presentation we heard this morning by the project officer, which is talking about the data spaces. And this is very much what we're looking at, but with a different focus, which is mostly on focusing on the delivery of applications. So I think once we've done that, then we need to understand what are the user needs and how we can support the user needs. And I think this is where the use cases come in. So in DigiBuild, for example, we're looking at the Web of Things to test on provenance, and that is a core component to identify that heterogeneous multi-stakeholder interaction of bringing the data. But then the lightweight integration layer, which is facilitated by the ontology, needs to be useful for the upstream applications. What we're looking there is we're looking at the building lifecycle, and we're looking at challenges associated with the building lifecycle. So very similar to what has been discussed and you were working in the BIGG project. So we have data that can be quite complex, like building information model data, and we have quite a lot of these for our cases. So kind of very bottom-up data that focus very much on describing the building and the building context itself. But it might be that we have more soft data which are related to users, which are related to prices, which are related to operational aspects. So what we're looking at use cases in particular is topics like how to support facility management, how to provide services in support of inefficiency identification, performance optimization, use cases related to benchmarking, managing of district systems, decision-making in relation to upgrading a system with digital aspects and digital elements, and supporting the decision process so that one can extract value from digitalization technologies and information technologies, and how this can be facilitated, and understanding it in the context of a financial dimension, which is important in supporting and kind of facilitating acceleration of the adoption of such approaches. So the ontology is like the arcane part, and we try to hide as much as possible and kind of highlight what is the value associated with that. And I think the big value is that reusability and kind of the opportunity to extend some of the notions. And then we try to demonstrate that within the context of the use cases that I described.
Thank you. Thank you for sharing this view. Katerina, we have 1 minute. Sorry.
Yes, basically, I would like to add that because we have made a lot of stakeholder consultations and we have several pilot partners that are facility managers and from the real estate, etc. That what was important for them was to have something that is user friendly and can somehow extract the information and input some information that for the building that are familiar to them. So we tried, for instance, in ENERGATE, we tried to have a marketplace, a platform where when we ask for building data to be on the one hand easy to find and to fill in those information that are needed and the data, and on the other hand those data to be enough for us in order to have some services and work with them and provide several, let's say, recommendations, for instance. So we have several services that we are exploiting, and some of them are also related to the big projects. For instance, we have a service that we provide identification of the best renovation practice for buildings inserted in the platform through comparisons with similar buildings that have been renovated in the past and are available in our database. So we have also service that is responsible for identifying buildings that are similar to the ones inserted through the platform. So it uses machine learning clustering with related building and energy data in order to identify, for instance, similar buildings that have already implemented energy efficiency measures. And these buildings can help building owners and implementers find similar buildings and extract valuable information for their measures and results. Another, for instance, service is matching buildings with technical experts based on predetermined KPIs. So buildings aiming to improve their energy performance through renovation will be matched with technical teams that can undertake the design and implementation of the renovation project. And also we're exploiting of using a clustering algorithm and based on the financier's preferences to identify the buildings that can be aggregated into a single project and be offered to the financiers. Just to be quite brief in a minute.
Yeah, thank you for the discussion. Thanks everyone, Dimitros, Katerina, and Daniel. Thanks for joining. I think we move to the next session. Nidia, thank you.
Yes, thank you very much to the panelists. And now to conclude today's event, we will hear more about 3 live projects. So today we will have 2 Ioannas. So first, Ioanna Andreoulouaki, who will present the INEX project. Then Ioanna Makaruni from the Audit to Measure project. And last but not least, Thomas Jesdinsky from the EUMOR. So Ioanna, the floor is yours.
So hello everyone. First of all, let me introduce myself. My name is Ioanna Andreoulouaki and I work at the National Technical University of Athens as a researcher. And today I will present the INEX's project to you. So the next slide. We will have a look on the general concept of the project, the objectives, the partners involved, and its scope. And then we will delve deeper into the specific business cases and the services deployed within the project. So on the next slide, you can see that the INEX's project is an EU-funded LIFE initiative coordinated by the Institute for European Energy and Climate Policy. And the most important element of the project is the deployment of integrated services, as well as the recognition of energy savings. This will enable the improved implementation of the Energy Efficiency Directive and assist the stakeholders in including both energy and non-energy benefits in the services they aim to offer. In the next slide, you can see that the INEX's vision can be described through 3 main goals. So the first goal is the creation of novel business models for integrated services, accompanied by appropriate contractual schemes. The second is the incorporation of innovative technologies in those services through a loop of deployment, assessment, testing, validation, and reassessment based on the received feedback. Finally, the smart energy services developed within the INEX's project will be exploited and replicated by key market actors, hopefully. And yeah, here on the right, you can see the map of the INEX's consortium. It consists of partners across Europe with expertise both in the IT and the energy sector. So in the next slide, you can see the INEX's business cases. So the INEX's project will be applied through 4 specific business cases. And the first business case regards energy efficiency renovations of buildings in Germany. And the energy performance contracts will be applied with pay-for-performance guarantees. For the second business case, the vision is to improve self-consumption and demand a response in an energy cooperative in Spain. As far as the third business case is concerned, it takes place in Greece and regards flexibility services for natural gas boilers. And the fourth business case regards smart energy management, while there is also a fifth business case, a conceptual one, regarding a decentralized energy efficiency power plant. So how we will actually implement those cases, you can see in the next slide. The smart services developed within the INEX's project will be implemented through a distributed ledger technologies platform. This platform is specifically tailored to the needs of the energy sector, which is really important because it enables smart contract generation, linking physical contracts with the digital world, tokenization of energy efficiency and flexibility services, as well as handling of both energy and non-energy data via blockchain. And on the next slide, you can see that INEX is expected to have a significant impact, launching several innovative services to the market, triggering energy savings and investments, creating policy recommendations, and training numerous stakeholders through capacity building activities. On the next slide, you can see the whole INEX consortium, and you can also find us on social media. You can see on the next slide our hashtag and the website for the INEX project to find out more about us and what we do. So that's it from me. Thank you very much for your attention.
Thank you very much. So now we will go to Audit to Measure project. The floor is yours, Ioana.
Hello, yes. Thank you for the invitation. My name is Ioana Makaroni. I'm a senior researcher and project manager at NTUA, the team EPU. So the same as previous Ioana. We are partners in the Audit to Measure project. We are leading the work on assessment and benchmarking of energy efficiency measures and the work on digital tools for the industry. But next one, please. Okay, so the full title of the project is Leading Business Towards Climate Neutrality by Speeding Up the Uptake of Energy Efficiency Measures from Energy Audits. It started in November, so it's already 1 year into its path. It includes 10 partners from 6 member states. Next, please. We are working, so from the title, we can deduce that you can see that we are working on energy efficiency for the industry. And we are trying to address the challenge that a small percentage of the recommended measures that come out of the energy audits are eventually being implemented. So this is the challenge that we are trying to address. So what the EC expects from projects like ours is to organize specialized actions supporting consulting for consulting and capacity building in the companies, and providing operational support as a service to the companies towards the whole path, let's say, from the audit to the implementation, with the objective, of course, to increase the rate, the implementation rate of the proposed measures. Next, please. So we are working to push for the uptake of the measures. What we are actually doing is we are developing and implementing a new engagement strategy, which will address the barriers towards the whole path for the adoption of the ESMs. And we are developing a capacity building program, which covers all the hierarchy within the company. So we are targeting decision makers as well as operational staff of the companies, and we are providing also direct support to the businesses towards the objective of eventually seeing some actual results. Next, please. So our methodology covers 4 layers. The first one is a status quo analysis, which has been implemented during the first year. So we did an analysis of what are the expectations and what are the requirements about the auditing system in each member state. What are the barriers that are being identified for the adoption of the energy efficiency measures in industry, for the industry? What are the decision-making paths? Because we understand that most of the energy-saving measures are prevented even at the inception phase, let's say, and also about the support and the funding mechanism, that the related support and funding mechanism. The next level is about developing the strategy and the tools that are important for the companies. So we are developing an audit to action strategy. This is what we have called. We have already developed the first draft of it, which is the target is, of course, the companies, the industry decision makers, about guiding them to the whole process. And then we have tools about the assessment of energy saving measures and the benchmarking methodology for the various energy saving measures in the industry. And also we have developed tools for assessing the energy management maturity of the companies towards implementing energy management systems, potentially also ISO 50001. The third level is capacity building and direct support. So this is where we are now. We have finished with the first, let's say we are finishing with the status quo analysis and the tools that we need. And we are already building our approach for the capacity building and the direct support to the industries. So for the capacity building and the direct support to the industries, we are already implementing laboratory of ideas, which is meetings actually with high-level management of each industry in specific. So we are working at the national level with bilateral meetings with the companies. We are organizing trainings for medium and low level and lower level management and energy auditors. We are organizing workshops for industrial associations, and of course, the most let's say not important but critical part is the part where we are identifying specific measures, and we are supporting the companies in implementing them. The final level that we are working on is the validation and evaluation of our strategy, which includes, of course, the development of a knowledge exchange space, and of course, providing guidelines both for the auditors, the energy auditors, and for the companies. And of course, recommendations for policymakers in order to address the legislative, let's say, barriers and things that can change at an institutional and legal level. Next, please. Okay, this is the timeline. I think I can skip this one, but as the main point is that we have already finished with the status quo analysis, and we are finishing also with the development of the tools and of the tools, and we are starting with the capacity building and the direct support to the companies. Next. Now, when we say direct support, what we work at a national level. So each one of the 5 countries involved, the 6th one is not involved in this part. That's why, I mean, there are 6 partners, 6 countries, but 5 involved in this part of the work. So we are targeting 25 energy saving measures per country. Let's say total of 125 energy saving measures across various, of course, technology groups and industries. So we have industries covering machinery, paper, ceramic, machinery, food, pharmaceutical, etc. And we have technology groups from lighting to process heating, of course, heating, cooling, of course, building interventions in the building cell, drives, motors and drives, fleet, digital tools, and this is where I see a lot of interaction and potential leverage of the projects that have been presented so far in this workshop. So we are targeting to support 125 energy saving measures. Next, please. Now, the benefits for the companies, apart of course from the energy saving that they are going to achieve, is the improvement of energy audits, is supporting them to get direct, supporting them in various, to get expertise and answers to various technical, financial, and legal aspects that, you know, might be a burden for them and a barrier for them. They are, of course, following the trainings for their staff. This helps a lot improve the culture and the operational efficiency related with energy efficiency measures. Of course, their access to the knowledge exchange space and the database, where they will be able to exchange views and information with other peer companies and with experts. And of course, their promotion as being part of this whole group, let's say, through the networking sessions that we are organizing. Next, please. Maybe the next one, even the next one, next one, and the next slide. Oh, there was animation. I was not okay. So here I have put in one slide the results that have been that we have developed so far. So we already have reports published about the state of the art of the auditing system. What is the status of the energy saving measures implementation in the industries in the 6 countries? We already have a report about the barrier, the identification of the barriers that we have, and the decision paths and the barriers that we have identified. We have developed a database, I call it a database of experiences. So it's actually a database that includes more than 3,000 energy efficiency measures in the industrial sector, where we have implemented our assessment methodology and the benchmarking methodology. So there is a lot of information there, a lot of graphs, a lot of information about the assessment on the various KPIs that we have identified. And we have also we are actually in the next month we are publishing the tools for the self-assessment tools for the energy management maturity of the companies. The next slide, I think it's about our website, the Audit to Measure website, where you can see more information. I hope I was not too late. I took note that we had to be very hasty. And I'm, of course, at your disposal if you have any questions.
Thank you very much, Joanna. So now let's move to the third live project, the EU More project. We have today with us Thomas. So maybe you can start.
Yeah, I hope you can hear me.
Yes. Yes,
Hello?
we can hear you.
Yeah. First of all, thanks, Nerea, for this kind invitation. Always good to connect with other European funded project. Second, apologies to the audience. I cannot switch on my camera, and there may be some back off noise. I'm sitting in a coffee shop because of urgency construction work in my house going on. So I try to be as brief as possible. EU More, next slide, please, is an acronym for European Motor Renovation Initiative. In a nutshell, motors are much older in buildings and tertiary sector, but mainly also in industry, than we think. 30, 40, 50 years still running, so meaning they have a lousy efficiency. And if we replace them before they fail, we can harvest, before eco-design happens, additional energy savings. Next slide, please. So as all projects, we're organized in so-called work packages. The important here is in the middle. The work package 3 is really a knowledge exchange platform where I invite all of you interested in a topic to participate. There's a backdoor forum after registration on our website, where on the one hand, we share what we have analyzed on the left side on policy, existing policies and policy measures, proposals, and on the other hand, on the right side, tools for monitoring and evaluation of the outcomes. Next slide, please. 6 partners in the project: University of Coimbra, ECI, European Copper Institute. I am representing here today. IACP, Austrian Energy Agency, CREST from Greece, and Fraunhofer from Germany. Next slide, please. So again, summarizing the problem, electric motors account in total for more than half of our electricity consumption in the European Union. There are over 8 billion motors running every day. We are addressing a motor, we're not addressing the small ones in appliance or in automotive. So we are really coming from, let's say, 1 kilowatt or slightly below 1 kilowatt to a couple of 100 kilowatts. And these motors are far older than we all expect. Next slide, please. So the impact study was based on assumptions saying these motors are something between 12 and 20 years. But next slide, please. In a Swiss study from also not a recent one, but I think this is still valid, you see this is a logarithmic scale. Most of the motors are 20, 30, 40 years old, regardless of the size of the motor. So meaning they're running far beyond the expected lifetime. The next slide, please. And a similar study, a recent study in the US, basically tells us the same. The lower bar, UTC, means unknown nameplate, which means that they even don't know how old these motors are. But from what they know is many motors analyzed in the study are 20, 30, 40 years old. Next slide, please. So eco-design happened like 12 years ago in 2011. So you see that now the motors sold have a relatively good efficiency, but as I explained before, the motors still in duty are much older. So they're on the left side and they are IE1 and below. Next slide, please. And if we go here to the very right bar, then we see red and yellow, which are the critical low efficiency motors, are still about estimated 70% of what we have in the market today in Europe. And these we are addressing in our project to replace them before they fail. Next slide, please. Yeah. So just to put some numbers, we expect electricity, if we could replace all of these old motors before they fail, this would mean 100 terawatt hours per year. So like 55 gas plants, it's the entire electricity consumption of the Netherlands, or 30% of what we have imported in natural gas from Russia before, and 25 million tons CO2. Impressive numbers, of course. We will not materialize 100% of this, but even a 10-20% portion means that we are talking about big numbers here. Next slide, please. And emission reductions is one milestone in industry, but also in tertiary sector, to go to a net zero emission scenario. Whatever you take, you can take the STEP scenario, for example, from International Energy Agency, and this is one of the could be one of the contribution here to go to this net zero emission scenario. Next slide, please. But of course, we have barriers. So we have practical barriers. Industry and also building owners are rather conservative. Don't touch my process, don't change my system. There are economic barriers because the payback time seems not favorable. There are split incentives, so the process manager and the maintenance managers are not linked directly to the energy contract. And of course, there are barriers at policy level. So there's a lack of data and a lack of insight which policies works best for accelerating motor renovation. Next slide, please. So what we will try to do is gather insight, do some clever modeling, data, and analyze policy scenarios and also their impact on energy savings. As I said before, the core is the knowledge exchange platform, where we try to link policymakers with industry people, with building owners, and all stakeholders together to propose then policy developments, stimulate system efficiency. Also, not only the motor itself, but also like frequency inverters, variable speed drives, digital monitoring of the motors, which could then be linked to data platforms and data collection usage you have proposed here in your projects. And ultimately also to promote circular economy, meaning use the recyclable materials, recover them, and put them back into the process in Europe. And next slide, please. So here you find all the information. As I said, on the website, there you can register for our forums to engage with other stakeholders. We are on LinkedIn, and there's a newsletter you can subscribe to. Thank you.
Thank you, Thomas. Thank you very much to all the participants and of course to the speakers for all these comprehensive presentations and discussions. So just as a reminder, next week we will publish the slides and the recording. So you will find there the contact details of the speakers in case you have any pending doubt or question. And as I cannot see any question in the Q&A tool, I think that I will give the floor back to Maria to conclude this event.
Hello again. I think we are late enough, so I will try to be fast. I just, to wrap up a bit of the conclusions that we have during the meeting, I think that, there's 4 or 5 thoughts. I think that ontologies, we all agree that ontologies are essential in order to achieve data interoperability. I think it's critical, and it's not only something to be applied on the energy sector. I think that there are many sectors with a lot of heterogeneity in the data sources, and ontology semantic interoperability is key for that. But I think in the different examples, we all agree that ontologies are very difficult to build. The strategy would be to rely on existing ontologies and to propose extensions for those ontologies. I think that some projects experimented the fact of, okay, let's try to build an ontology, and it's not really reasonable. There is a lot of effort and standardization behind that. So let's say it's better to analyze the weaknesses of the system ontologies and try to improve them. The other comments that I think we mentioned several times is about the artificial intelligence. That is a powerful technology in order to apply, in order to help decision makers to make this decision. I think that it's something that it's clear in several projects that decision makers need additional tools more precise than the ones that they have now in order to make decisions about the energy efficiency and especially about renovation. Also, it's important to understand the needs of the financial entities in order to support this renovation and investments. And something also that was mentioned several times is about the need of having user-friendly tools for them in order to, even if the data management and the data, let's say the services are complex, at the end of the day, we need to give them very user-friendly tools, both for decision makers, but also for the final user, in order to understand what's going on, in order to make easy decisions based on complex data, but that let's say that the tools that we provide to them are easy, are conclusive, and are helping them to make this kind of decisions, right? And to be transparent. For me, those are the main topics that throughout all the presentations I collect as the main and most repeated, let's say, items that we mentioned. And for me, that would be, it's a perfect combination of projects. I would really appreciate all the people that help building this workshop, which I think is a really a good combination of knowledges and targets, and all very well aligned. And yeah, as Nerea said, I hope that we can still contribute regardless that the big project is going to be finished soon. I think that the collaboration will be still there, and we are very happy to continue these liaisons with all of you. I would appreciate all the audience for being here. Thank you very much. And Nerea, if you have something else, please, the floor is yours.
Nothing else to add. So yes, thank you all. Thanks the audience for being here today with us.
Thank you very much, everybody.
Thank you very much.
Thank you.
Bye
Have
bye.
a nice
Thank
day.
you. Bye.
Have a nice
Thank you.
afternoon.
Bye.
Bye. Thank you.
Bye.
Bye.